My presentation is more of an InfoSec red team kind of view presentation. And it also pertains to, I would say, blue teamers, because the blue team people are going to go, what just happened? And the red team people go, look what I found. And everybody else in all the other groups are going to go, no, that can't be happening. So that's really what I want to talk about. But of course, this is SharkFest. This is Wireshark. I'm going to be using Wireshark a lot. All right. So this is not just about kind of what my title is. This is some of the capabilities of what we can see and what we can do and how we can work towards some understanding of what's going on the network. So I termed this the I'm in your net, and I'm exploiting your v4 network with v6. The premise of this is that the most entities still today, we are 22 years into IPv6 being a released technology, and most people still not doing it. And now I'm going to use what I would call the air quotes, and you can kind of see me almost doing formally. So that's a little bit of what I want to talk about. And this whole concept of is, since there's so many people in their networks not formally implementing IPv6, they're not running IPv6 in their network. And because of that, there's a massive attack vector, okay? And so this whole concept of what I want to talk about is doing just that, all right? A little bit more on that coming up in a minute. So who's Jeff? Well, Jeff works for Hewlett-Packard Enterprise. I'm in the education services team, and I am an instructor and course developer. Okay, that's it. This is not HPE. This is not about HPE. And in fact, this is all about having fun with packets. So that's a little bit about me. Talking about IPv6, I've been formally working with v6 for a little over 11 years now, I would say, in a semi day-to-day basis, and actually upwards of a little over 20 to almost 21 years ago was my first touch in it, right after it became the original standard release. So you can find me in V6 land talking about stuff, in Twitter a lot, and having a good time with it. So that's just a little bit about Jeff. I want to spend a very short amount of time in a slide presentation. I just want to talk about a couple of V6 fundamentals, because I want to make sure we're all on an even space when I'm talking about this V6 bit, and I'm pointing out very specific things. So a quick little survey. If you could raise your hand if you've worked with IPv6 at all, whether you've touched it, you've seen it, you attended any other sessions, presentations, courses, or whatever. And all I'm looking to see is if some background knowledge of V6. And by the way, I've got all kinds of different screens around me, so occasionally I will look away from the camera. I apologize from that aspect, but I'm here. So I'm looking at our attendee list, and about half of y'all that are here today have worked. Oh, the number's increasing. We're up to about 2/3. So that is awesome. That is awesome. So go ahead and drop your hands. And my next question is going to be, who attended Rolf's intro to V6 of the last session? Certainly not a prereq, but I'm going to raise my hand. I did, and good. Many others did as well. Okay, that's good. Go ahead and lower those hands, and I've got one more question, and then that's enough. You know, what it's like, Jeff, Friday afternoon or Friday morning or Friday night, whatever that time is for you. What are you doing asking all these questions? One more question. Who is on purpose running IPv6, whether it's in your home network or your work network or in a lab? On purpose, you are doing some V6 stuff. Okay, that's nice to see. Quite a few are. So therefore, my question is, why are you here? You already know it. You're experts, but that's okay. Maybe I'll have some little tidbit that I can show you today. So that's what I'm going to talk about. A little bit of just some fundamentals about the addressing. Very quickly, 128-bit address space, 64 bits are the network, 64 bits are the interface ID, or what we would have called in the v4 world, the host address, okay? That's just the way it is. A lot of people look at that and say, well, that's a supremely large space for host addresses. Yes, And that's the way it is. All right. Many operating systems won't allow you to make a larger network and smaller interface ID space. Some may, just don't. This is the way it's built. This is the way it works. And yeah, you could have 18 billion and change possible host addresses. Well, that's the good news. That's what makes the blue team happy. And we'll talk a little bit about some of that. Some of our address types. The easiest, quickest thing to know is there is no broadcast traffic in V6. All right, everything that you would think of as broadcast traffic, basically on-link type, I want to talk to my neighbors, is a on-link multicast. All right, so we have a multicast prefix for on-link, we have a multicast prefix for off-link. All right, just kind of go from that. We still have a broadcast domain, that's your layer 2 space. All right, but from the kind of the IP perspective, we don't have that broadcast identified traffic. A couple of address types in V6. There's a link local address that will always exist on a V6 enabled interface. That's one of those pretty much a solid rock, okay? No matter what, you will always have what's called a link local address. A little bit more about that in a minute. In a V4 world, that's that PIPA address that we've had for some number of years, but it goes away in a V4 world. The link local address never goes away in the V6 world. All right, that's just the way it is. Internet route capable addresses in V4 world, we call them public. In V6, it's what's known as a global unicast or a GUA, G-U-A. All right, I'm going to be throwing out that GUA acronym a lot. In the V4 world, we've got our RFC 1918, quote, private addresses. We use NAT to get off of those to a public side. V6 has a comparable address space known as the unique local or the EULA, but there's no NAT formally to help use that to get off. So basically, we're done with private addressing. There is no need to do it. Now, that's just one person's opinion. There's a lot of discussion about that, but we're not playing with EULAs today. We're playing with link local and GUAs. That's it. When we start looking at that, we specifically want to understand what is the prefix space. So very specifically, your link local addresses are prefixed with FE80 : All right, first 64 bits, the network is an FE80. All right, the last 64 bits of the node address, how we get that comes up in a second. Global addresses, global unicast or GUA addresses are in the 2000 to 3 FFF space. However, right now, they only come out of the 2000 range. That's all that's been allocated for use. All right, there's another address to know about, this 2001:DB8::. That is in the global unicast space, but it is reserved for local nets only or local domain network only. You can route with it, just not off of your domain. Pretty much used for lab, private labbing, documentation, exampling, etc. Now, I will be using that in some of my lab work that we'll see today. So FE80's link local, 2000 something is a GUA, 2001:DB8 is a on domain route capable address only. Some of the prefixes, I'm not going to spend a lot of time, but we are definitely going to see some of these multicast prefixes, very specifically like the FF02 ::1 address. We might see that here and there. So we've got that out there. Interface IDs are derived at one of two mechanisms. The original spec was to take the MAC address and invoke an existing standard from IEEE known as the UE64, which took that 48-bit MAC address, shoehorned in FFFE in the middle, and that was now a 64-bit address from a 64-bit number from a 48-bit number that was unique. All right, this was a unique component. Give a little star there, generally, supposed to be. The V6 team, though, said, no, what, we need something that gives us a little bit more uniqueness to this. So they went over, took the 7th bit of the first byte, invert it, and now that 64-bit number is what we can use for an interface ID, and we know that it's derived from a MAC address. That's the good news. The bad news is it takes all about what, 3 seconds to reverse that all out, come up here, get the OID, research who that belongs to, and now you can sit there and do a little recon on a local network and figure out all the different brands of the devices, at least of the network cards. But sometimes that'll pretty much give away the device type even, because it'll depend on what that manufacturer has used that MAC address. So another standard way of getting these interface IDs that need to be unique, right, across every address on every interface is using a random number process. That's the good news. The second part that they did to this was making the standard say, not only are we going to generate a random number for 64-bit to use for an interface ID on interfaces, we're going to generate a second one, call it the temporary, and recompute that temporary on a periodic basis. The whole point of this is we don't want to be tracked. In the modified UV64 way, Jeff's laptop can be seen all over the world based on where he is at the time and go, oh, there's his MAC address. There's Jeff. All right. Even in the random number generator, my interface ID quite often will be the same for some periods of time, depending on the operating system and some of the other operational aspects. So this temporary address is even more supposed to be unique. And sometimes we see it as, and sometimes maybe not so much. In V6, the addresses have a lifespan, and a little bit different in V4, we actually have 2 kinds of operational portions of lifespan. We have I can do everything during my preferred lifetime. Then when that's over, I have a little bit of time left that I can finish up my business on that temporary address until a new address is computed and I can start moving all my traffic over to this new address. This actually allows a couple of things. One, that temporary address to keep morphing. 2, you can actually readdress a network on the fly in the middle of the day and nobody would know. And that's all the great news. The not so fun news is when your address changes, if you've been running a trace between, say, client server, and it's packets flying, and then it just dead stops. We think, okay, the system's broken. No, it's probably still going. It's on a new address. So troubleshooting in this mode sometimes can be a little challenging, but address timers here being a little bit different than V4 is kind of interesting. There's 4 specific IPv6 message types we're going to be seeing. You can see their names there. I'll get to those here in a little while. Another component in V6 is in order for me to use that address, I need to validate that it's a good address. So I must do the DAD test on every single V6 address that I want. Link locals, GUAs, EULAs, it doesn't matter. Every new one, I have to do the DAD test. The interesting part was, it used to be I had to pass the DAD test before I could use the address. Well, we had some problems in timing that sometimes timers would affect us that we couldn't keep going on our network. Because we didn't have an address to use yet, and applications like logins would fail. So they changed it to say it's deterministic DAD. Get a new address, start using it, do the DAD test at the same time. The problem is your DAD test could fail after you've already started something. So just hear that, and we'll see the DAD test. And as another point of reference, looking for DAD packets is going to be really, really important, as you're going to see. The whole bit about V6 is the capability of auto-addressing an entire network with only touching a single device, that device being the router. That whatever is doing V6 routing on that subnet is what tells everybody what we're going to do. That's a whole big difference in V6 compared to V4. Do I want you to use me as the router, and here's your router or your network prefix, and I want you to come up with your interface ID. We call that stateless auto configuration, Slack. And that is a default operation, and it only requires the router config. The driver side, it's all written to support that. But that didn't solve everything. Initially, it didn't give you DNS, didn't give you your domain name info. So you still needed a DHCP type functionality. So we have DHCPv6, but we have to then set different flags in this what's called router advertisement to tell everybody how to get their addressing. So when you flip a couple of flags around, it now when a client will see a router advertisement either during their periodic send or a specific request for it, they will go, oh, I'm supposed to look for a DHCPv6 server. So now I will send out a message, hey, any DHCPv6 servers on link. And whether they are or they're off with DHCPv6 relay, we can then get those addresses. And I know who my router is, and now I got my address from a DHCPv6 service. Sometimes I want the hybrid portions of those. I want Slack for my addressing. I want to control my addressing, but I also need DHCP options like download servers, time servers. Maybe I still want my DNS and domain name stuff to all come from that. So I can do what's called stateless DHCPv6, flip a few more flags. All right. The bottom line on these flags, and there's 4 specific flags that are in the router advertisement. There's more, but these 4 specifics are everything that's dealing with addressing. And I got some really cool stuff to show you about how that's going to work. Set some culling rules up in Wireshark if you like colors, just to make it easy to find those V6 packets. You'll see that. Three primary V6 display filters in Wireshark. We'll be using a lot of display filters in the Wireshark coming up. There's that reference sheet. Again, it's in both the Zoom rooms. I hijacked the Zoom 1 room, put it over there. It's also a link in chat. And I hope you have fun with it. Rolf also posted one. Go back in a Zoom 1 room, go up a little bit there in the Discord Zoom 1 room, and you can find Rolf's download for his V6 reference card. So thanks for that also, Rolf. Last little bit, there's a number of books that are now about in the middle 2010s of release they're out there. They're great reference. Of course, I'm going to give a shameless plug for a book that I was a part of, the Guide to TCP/IP in both the 4th and 5th editions. I was the major V6 contributor, content contributor, but plenty of good reference materials with all kinds of focus on V6. You'll see those when you get access to the presentation. All right, done with books. This recon, all right, here's going to be the live demo. I am going to access a real live network on the internet. All right, it's my network though. I'm going to give you that caveat. This is not somebody else's. It's not Jasper's network or Saka's network. Okay, it's my network. I promise. And I'm going to be doing things. However, don't do this if you don't have, and now it's a almost written authorization, and it better be really good, a defendable in court written authorization, right? Don't just assume that if you're a part of a company that you can start doing some of the things that I'm going to do and show you here, and you're safe, you know, from legal repercussions. So that's my big disclaimer in all this environment. What am I going to do? I'm going to find an exploitable system on the internet on V4. I'm going to validate whether or not it even looks like they're running V6. Yay, they're not. Okay, it turns out the system I found is way exploitable, and I'm going to do things like use that as my little Trojan horse. I'm going to fire up VirtualBox. I'm going to fire up some VMs. Those VMs are going to be routers. They're going to be a couple of Linux boxes. I'm going to fire up Wireshark. All right, and then what I'm going to do is be able to at some manner start snooping around on the network in a V6 transport mode, and nobody's watching, because guess what? They're not running V6. And if you're not running V6, are you watching for V6 traffic? No. Oh, and guess what? A whole lot of the IPS IDS systems don't even have V6 capability. Yes, our routers do. Yes, our firewalls do. Yes, you could still see it, but it's not necessarily being looked at because we're not running it. All right, especially on the inside of the network. So yay, I'm expecting that. And I've got some really cool red team views to look at here. And not only that, now that I've got V6 running on this network, I can access devices that are on that network on V6, and people don't know it. Yay! All right, we're going to have some fun. All right, so before I do run out of all my time and running at the mouth, thank you for coming to my session. We're not done. The best part's just fixing to happen. Thanks for coming into SharkFest. And I hope you enjoy the show. All right, so here's the show. I have, and you can see, please don't attack my box over here, but I am truly on um, a publicly available system. All right, but again, I own this. This is Jeff's. All right, I am not attacking anybody else's system, but this is truly on the network. It turns out that I found myself a server. Oh my goodness. And I got in on RDP. Now, you're going to have to give me a little bit of latitude in some of the things that I'm showing, but I still find in the InfoSec community people saying, oh yeah, RDP is still open a lot of places to the outside world. So I'm on a Windows 2008 server on RDP. And it turns out it hadn't even been updated in quite a while. So that to a certain degree is a little bit to my advantage, yet in some modes it actually isn't, because I couldn't run some of the newer version of the utilities that I wanted because I didn't have the right service packs. So we're also assuming that this is a server that's a heads down display. So there's not somebody sitting in front of this screen. Now, it doesn't mean they don't have logging on. It doesn't mean they're not doing any kind of tracking. The assumption is, though, that nobody's watching. So first thing I want to do is I want to get on this box and let's just find out what's running, and are they running any V6 networks. We start to look at a few things. I've got at least 3 network interfaces, hardware level interfaces, and none of them are running V6 from the perspective of a route capable address. All right, every basic server and client and now almost for the last 2 years, some router OSs have V6 enabled by default. And when you see an interface like this local area connection 1 or local area connection 2 here with an FE80 and that's all, that means they have not unticked the V6 protocol box like they did on this interface called Do Not Touch. All right, they unticked it because I don't see the link local, but these other 2, link local is still there. That means they're enabled, and I'm going to exploit that. Way fun stuff. All right, so that's just the very first thing we do. The second thing we do, we look at the rest of the interfaces. We can see some of those tunnel adapters, and in fact, we know to a certain degree the ISOTEP tunnel adapter was deprecated in Microsoft OSs 5-6 years ago, maybe slightly longer than that now. So this is another way I know that this is a little bit older based operating system. So there's like step 1 that's telling me a lot of good stuff right off the bat. All right. So I have already done some of the work. You don't need to watch Wireshark being installed as with other things. So we're going to fire up Wireshark. And one of the things I want to do is kind of determine a little bit about these interface cards before I start looking at them. So I want a little bit more detail about these network adapters. I specifically want to see what this configuration is. Oh, wait, I know what I want. I've got it right there. I can look a little bit at the V4 configuration. That's really all I needed, and I already have that in my IP config. So local area connection 2 happens to be this 1020/30 network, and I want to look at that one first. Local area network connection 2. So we're going to go look at that interface worth of traffic. And now we don't see a lot of just underlying traffic going on at this stage of the game. So part of that is we're just going to let this run for a few minutes. All right. And just see what we see, as it were, on this network. Now we should, and we are starting to see a little bit of traffic. And right now we see some layer 2, right? LLDP packets we see coming from a switch. Well, this alone tells us some information. This gives me, a wealth of information if I so chose. Some of it is, well, let's go look and see what in LLDP it's telling us. And we see now I've got my router where it wasn't configured over here for that network, but I see it. It does actually have a V6 address on an interface. Now, the more interesting thing is, even though it looks like you might think it's on the same interface, I do happen to know that this V6 address is on a different VLAN interface. So it's not on the same VLAN that this network is. we could try to do some things to get to it. But here's the thing, when I'm doing this recon project, my whole goal is to not get noticed. What's going to get me noticed if I do anything on v4, right? Because they're watching. They're watching from the outside world coming in. They're watching on the inside world, local attacks. So I don't want to do anything on v4. I don't want to ping. I don't want to telnet or SSH to that box, to that router, okay? Because I'm going to get noticed. Everything I want to do is got to be completely silent. All right, we are in silent running mode here. All right, the red light's on, we're heads down, nobody's watching us. And if I had my hoodie, you're right. Okay, let's play. Looking over at questions and everything's quiet at the moment. Okay, good. All righty. With this in mind, this is just giving us a little bit of information. Well, let's take this to the next step. Right now, we're not seeing a lot of traffic. We see some VMware traffic. You know, if we were to do a little bit more investigation on this, if we ran ipconfig /all, we can actually get some information that's going to help us. And in this case, for the local area connection 2, we see that this address, MAC prefix, is VMware. Okay, how did I know that's VMware? Well, one, it's my system, but two, I can go look up at the MAC addresses and see who it's assigned to. So now this gives me another bit of information of where I think I'm somewhat safe from being discovered just by what I've got on the screen and being RDP'd into it, that it's a VM. So yay, I'm on a server class machine that's a VM. So my guess is I'm on a server VLAN. Ooh, ooh, ooh. We might have a lot of fun. Don't know that for a fact, you know, just making assumptions, but we've got some information already. Yeah, I know we're not doing V6 yet. We're going to get there in just a second. So we've got Wireshark going. We've seen a little bit about the interfaces. There's like not much traffic at all going. Because we know this is a server, we're going to look for some applications and we're going to see something, oh, like this. All right, we see that's not what I wanted. I want to trim up my view here, get rid of some window, and I want to look, it's got a DHCP server. All right, so it gives us another bit of information once we look at it, because in 2008 server and above, V6 services were also available. We look further on there, there is no V6 DHCP services running, but there are a couple of scopes. So we know that this system, because it had two interfaces and different VLANs, it's supplying V4 addresses. All right, this is actually even more cool stuff. Again, we haven't really done anything yet, right? We're not out there reconning with V4 traffic. You don't want to do that. But I can get some really good information out of this. What I really want to know is these MAC addresses. All right. And if I just look at these host names that are associated, that tells me some bits, but I could have also found out from the MAC address on these. All right. And we look at this and we say, well, it looks like I've got a Raspberry Pi and it looks like I've got a Windows box. And start looking at these prefixes and I see that this Windows box, at least again by host name, is a VM. This Raspberry Pi, if we go to search its prefix, it's going to be a real Raspberry Pi. Woohoo! All right. Now we look on the same network we've been on, these local area network 2, the 30net. We see some similar modes of operating. A Windows box, an Ubuntu box. Those are both, it turns out to be VMware MAC prefixes. And this one also has a Raspberry Pi. So I've got some MAC addresses of devices. I can watch a little bit of the traffic that's going on. And again, we're not seeing any V6 traffic. We're going to throw in our V6 filter. Ah, look, we do get a little bit of V6 traffic. All right. And now we see from here, of course, that's a VMware prefix because Wireshark told us. All right. And we just got this little almost like DNS type traffic, you know, just trying to do some local resolution to see if we can find anybody. All right, so not much V6 of any real on-purpose traffic, just default operation. We can look and see a few of the devices on our network with their MAC addresses that can help us when we do the next bit. What is the next bit? The next bit is to fire up VirtualBox. Now, this was where I had a little bit of a challenge. I can't run the newer VirtualBox because the Windows. I can't run the newer Wireshark. In fact, kind of upsetting that I'm literally relegated down to 2.2.2 was about the latest one that I could get working without having to do any updates on the server. I didn't want to do any updates on the server. Again, I'm silent running. All right. So I'm somewhat, to my thinking, encumbered because I'm running on this version of Wireshark and it doesn't have some of the cooler, newer features. But you know what? It will get the job done. And that's the whole thing about this. All right. The job is still possible. Similarly, in VirtualBox, I had to relegate down to a little bit older version, and I can't run some of the other versions of the applications. Now, why am I doing this? I need to light up V6, which means I need to drop some V6 routers on these networks. All right, because the system I'm exploiting are not running V6. Well, I don't want to go, sniffing around on V4 transport, hammer into their routers and light up V6. No. I want to light up V6 on my own. I don't want anybody to know. But the cool thing about it is as soon as I do bring up a V6 router, we are going to see all kinds of V6 traffic. And that's exactly what I'm expecting to see. So I'm using a couple of VMs, VIOS, which was a fork from Viata, which was both a technology that was open source as well as paid for. VIOS has done the same thing. And I am going to start this. And this particular configuration of this VIOS system is set for the router advertisements to go out very frequently, which is not the normal. The normal frequency of a router advertisement to just send itself out is about one every 6 to 10 minutes. All right, I've got mine set to like seconds, like 2 to 3 minutes. All right, because I want them to go out frequently. And my router advertisement is set for Slack operations. All right, not for DHCPv6, just for Slack. And as this box starts coming up, and yeah, I've got to talk through it. Again, we are going to see all kinds of traffic over here in Wireshark. And as they say, yeehaw. All right, I am so looking for that to occur. And this takes forever when you're waiting, right? Waiting for this to occur, but it's going to happen and it's going to be fun. And we're going to reset these screens like I'm doing right now. So this guy is getting close, as they say, getting close. He's going to light up, and at any moment now, we are going to see, again, all kinds of V6 traffic. And that's why I'm already set for my V6 display filter, IPv6 display filter. I need my humming music. Oh, there we go. Look at that. I move out of the screen. Double colons in the source address is an indication of a DAD test. Well, that's this router coming up. All right, let's back up. My red packet, that's a router advertisement. This router advertisement is configured to say basically the appropriate flags. The A flag meaning everybody, if you get this, I'm your router, and you self-derive your own prefix. And here is our network prefix. All right, 2001 DB8 Lab 30. And the other flags that are important, the managed address, which says go ask for DHCPv6 server, and the O flag, which says go ask for DHCPv6 server for everything else other than an address, are not set. Now, once that happened, once once these devices started seeing this router advertisements, we will start to see some DAD tests. All right, so I'm going to flip over to a DAD filter right quick, and I can see some of the varying DAD tests that have already gone out. And we can see, even just looking at the last 3 bytes, some of these addresses. Well, let's go look back at DHCPv6, and this becomes an interesting thing. Sometimes, depending on the operating system, they may be set to running the random address or the random number generator to generate their interface ID. Sometimes they're set to the UE64. So I may not see a lot of MAC addresses in over here. And in fact, it doesn't really look like I am at all. So that's starting to tell me that a lot of these packets are using the random number generator mechanism to generate their interface IDs. That is very common in today's time at client OSs and server OSs. Client OSs kind of made a flip in the mid 2010s from UE64 to random number. Most network infrastructure devices, I would say, are still doing the UE64 mechanism. Now, one of the things that we can see, if you look down here in the bottom in the address, if you see in the 5th and 6th hectext boundary FF:FE, we know how that interface ID was generated. It was using. But since I didn't see it over here before, we just go with the last 2 bytes, Alpha Baker 10. Oh wait, we do see Alpha Baker 10. I was blind. I even had the packet. So look at that. That Ubuntu box is using not the random number generator. All right. So we see some of these components. We see that this guy has basically gotten the router advertisement, has configured a 64-bit address for interface ID, prepended the network 2001 DB8 Lab 30 on it, and now this has a global unicast capable address. And how about that? Now, it even turns out more fun. Let's go back over here and look again at our local connection area 2, right? No V6 generated address other than its link local. All right, I'm gonna go back to just this one, and now look. And this look is a couple of looks. We see on local area connection 2, he now has a single address. This is generated through the random number generator process, but it doesn't have a temporary address. And that is because the Windows Server operating systems don't generate a temporary because they're not moving and they don't need a temporary. Just get them a route capable address. They chose to set their bit off. Most client OSs, the bit is on. All right, so you'll start to see a number of different addresses on interfaces, and it's totally valid to do that. So right off the bat, on this particular network, we are already seeing all kinds of things. And if I go over here and look on this router, remember, I own this router. This is my router. This is my stealth router. All right, I can do things like look at my neighbor table. And I can see there's at least a couple of devices that this router has talked to. All right, we see both on some link local addresses as well as some of the global unicast addresses, the GUI addresses. We don't know what they've done yet, and that's okay. We just know that there's been a little bit of communications. Now, with that information and what I see here, what I see in Wireshark, let's go back into Wireshark. And we can see a number of other kinds of traffic that just lit up when V6 came alive. We see DNS queries going out. Now that that address is going out, we will see queries on V6 protocol. But the cool thing is in V4, V6, they now both ask questions in both. Give it to me in a V4 and give it to me in a V6. So they're asking AREX and quad A requests, quad A rec requests. So this is V6 asking for an address of V4 to resolve that domain or that host. And we could look at some other ones at some point down the road. We'll see the questions start to come through on V6 asking for quad AREX. All right, and I could build more complex filters to give me some of that if I wanted. DNS, I've at least got some just basic DNS only traffic here. I don't know if we're going to find it as quick, but I could build me a filter, right, to look for just quad A, either by knowing it or finally find one, as they say, and right click and build that filter. And right now I'm not going to do that because I'm just trying to show a little bit about what occurred as soon as I fired up a router on that network. But the cool thing about it is just seeing what occurred and seeing how much information I just got both from when I started with the initial attack in, as it were, all right, access in, to firing up this router on this particular interface. And we can see some of these different devices. Now, the thing that I would really want to start doing is perhaps going through and saying, well, what can I do on some of these devices? We know to a certain degree over here the kinds of devices, well, based on the domain name and on MAC address, what kind of devices they are. Raspberry Pi, I start thinking of some sort of an IoT device. Maybe it's got a little temperature sensor, an Enviro hat on there, and it's measuring temperature. This is a server, maybe in a rack, maybe it's a server rack IoT device. I see a Windows box. I figure that's some sort of utility jump host. I see an Ubuntu machine. Now, again, these are based on the name, but of course the name's probably going to reflect correctly. Who would think that I would be where I am at right now, sitting at home and, accessing this network? So with that in mind, I can start to do some things like, search on what some of these addresses are when I know what that MAC address is. And the downside is it could take me a little bit longer to build my filters, but I can see pretty quick a little bit of what's going on with some of my traffic. In fact, it's probably quicker to go back to the DAD test and start looking at some of these. And I can do my, I would say, my exploit either on the GUA addresses or even on the linked local addresses. Now, it gets to be a little bit challenging sometimes to do it on the linked local, just because you have to have a little bit more information, like one little piece. All right, not that much harder, but I like playing with the GUA level addresses. All right, and seeing what I can get out of those. Look at this address down here at the bottom. Lab 30::1. Well, guess what? What do most people do in their networks in V4 for router or whatever is doing routing for them? Could be firewall, could be a router. All right, they're either doing a .1 or a .254. And it's either for the real router or it's possibly for a front-ended load balancer. So most people, if they're doing V6 and adding V6 into their networks, especially on the inside, they use the same host ID. Yeah, okay, I get it. It makes life easy. But we might remember that I did fire up a router. So if I'm looking at this and I'm seeing that 30::1, remember that I'm the V6 router. Okay, so yeah, I probably am the 30.1, and sure enough, here it is. I don't need to go any further. That's me. Okay, so I'm certainly not going to try to exploit my own box, but we start looking at some of these other addresses, and we can start what I call gathering information. All right, so I just want to copy my value here. I'm going to bring me up a little notepad, and I'm going to resize my notepad. I'm going to start tracking some of these addresses. All right, and there's some reasons why I want to do that, because I just need to build a little table. All right, I'm going to reverse engineer what my network looks like, and with what I can glean from V4 traffic, and what I can not only glean and do on purpose with V6 traffic, I can build myself a pretty cool map of this environment. So we're going to start working on this kind of stuff, and we're going to get that right now. All right, so I need another box. Back to VirtualBox. I am going to fire up my, where is it? I have to look at all my notes, of course. I think it's going to be this one. I have two little utility boxes that I play with here. And so one of the little, I've got not only my VIOS router running, right, but I've fired up this little Ubuntu box to give me yet another another box that I can play with now, right? The server, I'm doing a lot of stuff on the server, don't get me wrong, and I may have already been found out, right? I came in RDP. If somebody's doing any kind of monitoring, they're probably watching me already, right? They're just waiting for me to slip up. If not, yay. I've installed some applications. Yes, that may have triggered an alarm, okay? Just all kinds of alarms may have been triggered, but to a certain degree, is it not expected that if that's a server that's possibly folks in the network, either in the NOC or in engineering perhaps, or in support, might be accessing the server? So are they really worried about somebody logged in on RDP? Well, probably not, unless they're tracking the actual source from the RDP. Okay, that's a little different. But just generically, there may not be a big concern because it's inside the network. They're watching on V4. They're going to get all those red flags. Nobody's doing anything bad there. I'm on V6. I'm on the box, and now I'm starting to do stuff on V6. So again, a little bit of latitude, what's going on here may not work for everybody's trial. And again, you would never, ever, ever do something like this without approvals and permissions and waivers and stuff that'll hold up in legal. All right. I only say that because some folks in our area a few years ago got hauled into jail because it looked like they were breaking into the network, yet it was on an on-purpose attack. But oh well, we won't go there. So I am going to try to log in to my system. And now, come on, it's still booting. I'm just way impatient. All right. Because also I'm running out of time, but I want to show you a couple of little things. Let's look at the address for this guy. So far, he has only a link local address, all right, on this particular box. And it could be, I need to go verify which network that I put this guy on. I think, oh, I know why. He's on the wrong network. Remember, there's two networks, two inside networks, local area network connection, local area network connection 2. Well, it turns out that he is bridged to local area network connection 3, and 3, as it turns out, is actually known as this other network, local area connection. So it turns out that he is on the 40 network. So I'm not going to see anything yet. Well, that brings up a whole new point. I've got another router. All right, so let's do a couple of things right now. First, let's stop the trace. I'm going to save it. Again, yeah, this might be a really big red flag, but I'm going to do it anyway. And I want to switch to my other network because I can. So let's watch on this network for a little bit of traffic and see what's going on. Oh, look, we already got something out there asking for DHCP. Well, as it turns out, 31 Charlie, no, I'm not even sure who that is. Somebody's out there asking for DHCP v6. It looks like it's another VMware box. We might be able to find out some other information about this. Right now, though, I'm not going to worry too much about it. Let's just see that, look, there's something out there that's sending out DHCP v6 messages without having been told to do that yet. Windows client OSs will do that because in most Windows client OSs, they've got that little box where they ported what it looks like to me, the same code operation that they had in v4. So you either give yourself a static v6 address or your box is ticked for ask for a DHCP v6 server, unsolicited. You weren't even told to do it and you're going to do it. Well, this is good news for me on my red team journey. All right, let's go fire up that other router. Because that router is configured differently in its router advertisements. It's configured with DHCP v6 flag enabled. Well, that's not the right. The managed flag is enabled to tell devices fire up. Not only do you hear me and I'm your router, but go send out these DHCP solicit messages. All right. In the old days, the acronym was the DORA, right, and V4. In V6, it's known as the SAR. I send out a solicit message. The DHCPv6 router, excuse me, DHCPv6 server will respond and advertise. I send a request, it sends a reply, SAR. All right, so we're seeing a bunch of solicit messages go out waiting for answers. I see another LODP message. It's another switch, an HP switch. It's a different switch. Let's go look and see what his addresses look like. And we see a V4 address on there. And oh, look at this. We see a V6 link local on this guy. That tells me that V6 is enabled on that box. This tells me something else. That is new for Aruba router, Aruba layer 3 routers, layer 3 switches of a couple of years ago. They added that in their code where V6 was enabled by default, and it's a DHCPv6 client config. So not only does it have a link local, but it's asking for a server for an address. Oh my goodness, that completely took me by surprise when I saw that happening in the labs. And guess what? We're gonna see this happening. This was not the case in infrastructure devices. This was not the case for a lot of infrastructure devices over the time, but it is changing now. Look at that. We're starting to see some DAD tests. Oh, they want a pink packet or red packet, not the dark red, the light red. The router advertisement packet just went flying by. All right, let's go look at our DADs while this is kind of building. And look at that. We're seeing some DADs. And look at the, this was, who was this? PC system. Do we get to see what his address is? Oh, my bad. He's going to be right in there. No, it's multicast. Where'd it go? All right, somebody. I lost it. I just fell apart. There we go. All right, FFFE, I see that. I start thinking older OSs, okay? Infrastructure devices, IoT devices where their code set is small, perhaps, okay? And so we're starting to look at this and see some of this going on. Part of that too is we look at that prefix, that PCS system. That is what VIOS uses as their MAC prefix. It could certainly be other devices. Oh, there's a Raspberry Pi. We'd seen that in the DHCP. There's a VMware. So, and look at the type of address that it is. That is typically from a random number generator, i.e. not from a DHCPv6 supplied address, because not only is my router configured over here as router advertisement with managed flag set, it is also configured as a DHCPv6 server. So he's going to reply out. And so with that, I know that my interface IDs will be much, much shorter, basically only 1 hex tech big, like that, okay? Lab 40 : 118. That's a DHCPv6 derived address. That's all I have to look at, partly because I know this particular config. All right, : 116, another one. All right, so we are getting a lot of information very quickly in this environment. I can go ahead and log into VIOS and I can do a few things. Go look at his neighbor table, and then I want to show something else here. It's I think I've got it right up here, and I do. So we've got a little bit of a neighbor table. We can look at our other local devices tables. And sorry, I just thought I'd look over and see if there's any questions or comments. Not as of yet. And let me do one other thing real quick, team. Give me just a second here. And okay, sorry. Okay, so with that, I want to switch back to, let's just look at, actually, I want to go back and look at LODPs, and I will tell you why. Because remember that router that was layer 3 switch down there? Well, by now, he should be saying, I've got a V6 address, all right? And looky there, oh, that's not good. That's mine. Oh, I picked on the wrong one. Hewlett Packard. Here we go. There's the link local. Where is his other addresses? Management addresses, management addresses. Why is he not sending out his global unicast? You know, it's like they say, the demos. Oh, wait, there he is. Hewlett Packard sending out 104254. That's what I wanted right there. All right, that is that system lit up. So what I'm going to kind of show you a back end thing here. Okay, so this is not from what I saw. Wait, forget about that. I've got a v6 address. I wonder, can I fire up TerraTerm? And can I go to that address? All right. Now let's, you know what? I'm going to play it differently here. I want to play this real world. I'm going to right click. We're going to go and copy out that value. I'm going to go into here, TerraTerm. In order to access this device on a v6 address, I need to wrap the address in brackets. Most applications are still requiring that, but not always. But this one does. So I can wrap this in brackets and just see if I can SSH to that switch. Well, looky there. He thinks he's starting a connection. Now, I could sit here all day long and brute force attack this, and I did, okay? And I found out its login credentials, and looky there, I am in. I am in that switch. And let's look at his running configuration. You will see something very interesting. VLAN 1, which is where I'm probably connected into, does not have a v6 address. The default code had it at enabled and its DHCP address, his v6 address set to DHCP full, which means you're a DHCP v6 client. So ask for an address. Well, apparently he did at one point in time. If we come over here and I've got a filter for looking at router advertisements and DHCP v6 traffic. And basically I could figure out in this configuration, show IPv6, 1.6. All right, we see there was his link local address that we did see earlier, and here is his DHCP derived address. And so if we kind of do a quick little scroll up here, we can see where he sent out his DHCP solicit message, and eventually we would find the reply back to him. And we can see that he did send out a request, and most likely that being one of those being the router in here, whatever replied back with, okay, yeah, well, there was an advertisement. I have to go through. The main point here is infrastructure device just got a v6 address, and I had a telnet session to it. Now, my telnet session dropped. And most likely, if I do a quick little look, I would have found out that probably his address timed out and he had to ask for another one. And there was a little bit of a delay in there, which is sometimes a little annoying, but nonetheless, that is a possibility. But the biggest point of reference is here, I'm on this box, but guess what? I probably just got discovered because look, they've got all log information going to a log server. So, did I just mess myself up? Did I just get caught? Well, I've got a utility that works as a log server. All right, so we can go into config and we could configure a VLAN 1111 and name rogue. Exit out, and I'm gonna go into a write mem, and yep, sure enough, they are sending logging information, which is expected. Okay, so I just kind of took a risk on myself by doing that. We see time and date, and if I can adjust that out, I could potentially find out that traffic, how that traffic was sent. And you know what? It's the classic mode. There we go. Maybe I can get it. All right, the startup config was changed on that that device. Now we don't know much else about it. So let me do this. Let's log out. And there's what I really wanted to see. All right, is not only did I do something and I just may have exposed myself, but worse than that, they actually could have seen me coming in. All right, they would have seen me doing a brute force attack. Now, it doesn't necessarily mean, again, just because that's being logged that they're paying attention. I don't mean that disrespectfully, but it does mean that perhaps what was going on, they had red flags when their infrastructure devices are being accessed. And then they could look at that and go, what? How did somebody SSH in this box from V6? We aren't running V6. Red alert, flags are going off. They're going to find me, right? Time for me to disconnect. So got to be a little careful when you're, snooping around, doing a little bit of recon as to what's going on. I'm running out of time, and I want to show you just a few more things that I can do, and only because because this was a DHCPv6 server also on this router, then I can see some of those leases that were going out. My lease times are also very short, and that is on purpose, okay? I wanted my lease timers to be short because I wanted the address. I want that's traffic, all right? On my other router, we can see some similar things with neighbors, but since he's not a router, not a DHCPv6 server, there's not a lot of extra stuff I'm going to see. Let's go back right quick to that Ubuntu box because we had now gotten a V6 address, because he's also listening to router advertisements, and he did come up with his own, V6 address because he was told to. And he's just using the A flag self-deriving. With all this, I gathered some information. All right, I gathered some addresses. So one of the things I'm going to do is with this box, I think I can get to it. I'm going to do a little bit of recon. All right, because this is my Ubuntu box, and I'm going to start doing this on V6. Don't run an nmap scan on this Windows server. Because it's going to be doing V4. Everybody's going to find it, but doing nmap-6, woohoo! I'm sitting out there. Look at my V6 traffic. All right, he's all running around. I'm going to do a little bit of a sweep out there, and I'm going to try to derive what kind of a device this is, what ports are open, right? And I can now just start doing that. I go into Wireshark, I start collecting those addresses. I start building a little bit of a map of what all the different addresses are as I see them. And I just sit here and take my time. The theory is I've got all the time in the world because nobody's watching me. And I can get into this, and I can do this, and I can log out, log back in, come back and forth. I can run some automated tests. I can do all kinds of things. All right. We found out by running this little nmap, it looks like it's a Linux. Okay. We can see it's got a few open ports, maybe hardly not. Okay. Yeah, SSH is open on it. Let's look at, what was it, 116 was that switch. I think 118 might be, it was Linux, and that was the only operating system, might be like that little Raspberry Pi. I don't know. But these are some of the things you can do. Okay, question. Yeah, we're in the official question and answer time, so certainly feel free to bring them in, and I'm just going to continue on for another couple of minutes here showing you a few things because there's just so much to do. But this was the whole idea. You want to see what's running on that network, run Wireshark, and yes, we've got multiple interfaces, so I kind of executed the component that I needed to, i.e. I fired up VirtualBox, I fired up some routers, and then you saw all these other systems just come to life from a V6 perspective that before we're only running in a V4 world. All right, and we can see on this box that SSH is open, Telnet's open, HTTP's open. Oh, Hewlett-Packard. Well, that's probably that switch. Yep, 4 Baker 00s. That's that switch that's out there. Well, we saw that 118. We could try another Terraterm session. Let's go to 118 and see if that gets us anything. And again, since we had known that that was probably the Raspberry Pi, we brute forced to it. I actually logged in with regular default credentials, and looky there, I am there, and I've accessed it through V6. You can see my session over here going, and now actually I don't want all that SSH traffic, so I've got another filter to get rid of the V6 SSH traffic and only just give me regular V6 traffic, all right, because I don't need to see all that SSH that's going back and forth. So now I could do things here. Now I want to be careful because that's a live system, so I don't probably want to do much else to it, but I can start looking at things like, well, yes, it's got an address. It's got its linked local, of course, and it's got two addresses, which means one is going to be the temporary and one is going to be the random number generator defined. And in this case, we actually see it. No, that's FFFE with a public side. So he's got both addresses in the Lab 40 network. Totally fine. I can work with him on both addresses if I so desire. So the bottom line is there's a lot that you can do in these type of, let's call it red team approaches. All right. I've been doing this presentation for the last couple of years, 2.5 or so years, to InfoSec teams, and the eyeballs just go so big, and everybody in the room. I did one, a private one for an entity a couple of years ago. We had 30 some people in there from every major IT group. We had the security team, network team, server team, desktop team, a couple management type folks levels, and we did not do it on the network. I did it, same thing that I'm doing here on my network. We had a much longer session time, but the amount of people, because they were not running V6. I mean, everybody's, no, we don't do V6. And I said, are you watching for V6? And they're like, well, no. I said, why not? Because we're not running it. Thank you. You know, and all the eyeballs lit. People were just completely trying to figure out what I was, and he just knew that it was magic. I said, well, if you set up a little test network, I'd be happy to show you. Well, we can do it on your production network if you'd like. Well, of course they said no, but the whole bottom line is just because you're not running V6 on purpose, that's why I can't say it that way, does not mean you're not running V6. This is one of the easiest ways to drop in there. Everything that I'm doing here is free. VOS, you can get some older versions of it for free. VirtualBox is free. Wireshark, of course, is free. All right. You can do it with all kinds of other utilities. I've got a Kali VM on here that's got all kinds of utilities. There's two primary V6 targeted security assessment tools, hacking tools. One called is the Hacker's Choice V6, and the other one's called the SI6 Toolkit. All right, both of those have some ways of building and crafting all kinds of attack vectors, testing vectors, all right, so that you can see what's going on in a network, you can validate what's going to happen in a network, but they are awesome attack tools. And there's no secret. I mean, that's exactly what they are. So be careful in your V6 journey doing things on a production network, whether that's your home network or office network or anybody else's network, because you don't want to light up a router just like I did on a production network, because everything's going to shift to you, and now all the traffic's going to black hole because my router doesn't go to the outside world. Now I could make it. All right, I could perhaps get this router out of V4 tunnel to a V6 system, and I could come in through that. And perhaps even fire up something over on that Raspberry Pi to build me a little tunnel across V4 that may not be blocked at the firewalls. So there's a lot you can do in this kind of red team approach to looking at these networks and doing these attack and recons. But is just be careful what you're doing. You might be watched and not know it, just like I was on that layer 3 switch. Okay, I'm looking over. I'm going to go ahead and kind of wrap it from here to give you a few extra minutes to navigate over to our last session. Unless there's any other questions, chats, I see none. Oh, there was a comment down in Discord. Yeah, lots of dad jokes in V6. Absolutely, got to run the dad test, right? A lot of fun. I hope you found this interesting. I know it was a little fast. There's a lot more I'd like to show, just not enough time, but this gives you that peek into what could go on with not a lot of effort. Yes, you got to have an access point in, an access point into that network, but once you're there, you might be able to do all kinds of things without anybody knowing. And that's what we're trying to do from a red team perspective. Blue team, better start shoring up, because everybody just saw how far I got, right? And I started logging into all kinds of systems with very minimal efforts. Now, yeah, somewhere around there was a password, username password attacker. But to the infrastructure device, gee, I'm going to make all kinds of assumptions because it was enabled and they left it in the config and didn't strip it out, which they should have. But it's not uncommon for even enterprise level configurations. Oh, well, I'm not using that. It won't matter. I don't need to take it out. It's kind of like, oh, no. If you're not using it, take it out. If you're not using it, disable it. All right. Doesn't matter what the it is, because don't assume that nobody's going to figure this out. Thanks everybody for attending. I appreciate your time. Have a good rest of your day, our last session at SharkFest, and have a great weekend. Thank you.